So here we are in an Excel workbook, one that is posted on Moodle and that you have access to look through the specifics. But this particular process model tries to calculate the flow of these three main categories for this Bunker Hill Cafe. In each of these pages or each sheet will have a different stuff or different thing that we track: people or labor, the flow of goods, the flow of money, and the remaining two tabs are a little bit of analysis that we'll talk about in a second. Helpful to have our process flow diagram, the one we prepared just a moment ago, here in the Excel workbook to help us check off that we're modeling all the important components. So you'll see that our workbook is set up with a series of parameters. These are things that we're trying to measure: how much is flowing from supplier to the cafe, how much is accumulating, and trying to create different measurements or metrics that are meaningful to our KPIs, in this case, looking at gross profit. We have a value, and of course, we indicate units. And we have two different types of parameters that we work with. One, of course, we have our uh, values that we input ourselves. These will be estimates, and it's helpful to color code which ones are you inputting as estimates. So we might assume that Bunker Hill Cafe at most can have two people working in it at the same time. This particular cafe really only has two checkout registers, so we wouldn't want to hire three people necessarily. And then for each of these lines in which we track either goods, money, or people, we need a different series of equations that'll tell us how much is moving through each of these three lines. So we see that there's a flow of labor from the worker to the cafe. There's also a flow of labor from the cafe to the customer. For this latter one, we really care about this idea that we need to figure out how much labor is required to flow from the cafe to our customer. Well, this value, which comes out to 11 person hours per day in this particular model, is something that is calculated. This calculation is based off of other estimates that we might have. These calculations, this should be estimated, are based off some estimates that we might make. Initially, we might assign a value that is our best guess. So we might make a guess that there are 30 customers per hour that come to the cafe and that the cafe is open 8 hours per day. As we begin to test and refine this model, we do a little bit of research. We might improve upon these numbers, measuring the number of customers that come to the cafe per hour, physically sort of sitting there and tallying the number of people, as well as things that relate to secondary research. We may add as much complexity to this model as we choose. So we recognize that there are periods of the day in which there are a lot of people who require a lot of help, but there's also slower periods where there aren't as many people coming through the cafe. So in this particular model, I'm going to say that there's a peak number of labor hours. There's a high point, maybe around lunch, when a lot of people are coming through the cafe, in which we need all checkout stations manned. We need two people working. So in this particular equation, I've assumed that on off hours, so not peak hours, so 5 out of the 3 hours, I only need one worker. But during these peak hours, I need two workers. And so I can add the number of hours operating per day, in this case B8, plus the number of peak hours to get an estimate of the number of person hours that I need worked per day, in this case worked by 1 to 2 different people. I may also make an estimate of this internal loop that says the number of maintenance hours of about 1 hour per day. And so my total labor demand, going here from the worker to the cafe, should be exactly the total labor required by maintenance and the total labor required by customer service. So my minimum labor required, 11 plus 1, gives me this 12. So this is a way that I can model how much labor is required to run this cafe based off of some estimates about how many people come to the cafe, how many hours the cafe is open. Again, this sheet, this part of the model tries to quantify each of these arrows. how much labor is moving from one box to another. We do the same thing for goods, trying to quantify how many sandwiches are required, are going to be purchased. That should be equal to the number of sandwiches sold by the supplier with some margin potentially. And so we build this model again, taking a lot of estimates and things we might estimate. So we're going to estimate that the per month, there's 4 weeks per month, that the cafe is open only during weekdays. We're going to inherit from our previous page. Here we can make a reference to the people sheet and say that the number of daily customers is 30, just as we estimated before. We take a little note to remind us that this is something that we have previously entered as an estimate. And again, we make further estimates of how many sandwiches, drinks, or snacks every customer might purchase. Not everybody's going to purchase a sandwich, a drink, and a snack, so some fraction, 80% of the customers will purchase a sandwich, 50% will purchase a drink, 40% will purchase a snack, so on and so forth. We can then multiply through by the number of sandwiches per customer per day, per month, to get the total number of each food category required, this flow of goods from cafe to customer. That should be equal with some overstock margin. In this case, we'll estimate 5% of the flow of sandwiches, drinks, and snacks from our supplier to the cafe. Again, we're trying to quantify how much is moving along these arrows from supplier to cafe and cafe to customer in order to try to understand how much is being spent on each thing and how much is accumulating. Finally, the most important tab might be this money tab, one that tries to measure how much is earned in revenue, how much is spent on salary, and how much is spent on the cost of goods. In each of these, I encourage you to poke around and try to evaluate each of these equations. If you have any questions, do let me know. But each of these are relatively simple accounting. We don't go into too advanced accounting methods here in this particular course, trying to quantify each of these arrows. At the end, ultimately, what we want to get is an estimate of how much this restaurant spends, the total costs, this coming from the money spent purchasing the food and the money spent hiring these workers. These costs are balanced against the revenue, how much money is earned by selling food products to our customer. We balance these out, the difference giving us our gross profit and the relative percentage giving us this gross margin, this key or this major KPI, which we'll highlight because it's very important, that indicates how well this business is doing and what we're looking to optimize. Now, one thing we can do with this model is not just measure the current state of affairs, but we can try to understand what are the main factors that dictate this gross margin. We estimated many things, and we have control over many different parts of this model. We, as a cafe or the cafe, can set the price of each of these products, how much a sandwich costs, how much a drink costs, how much a snack costs. We may be able to set things like how much we spend purchasing each of these things. We may be able to affect things like how many sandwiches or drinks or snacks a customer purchases by maybe increasing the marketing, making them more attractive, so on and so forth. For each of these things, we have many, many different factors that we could use and alter to affect this model, ultimately trying to improve this gross margin. For that, we look at a few different options. One thing that I encourage you to make use of is what we might call a tornado chart, which is a sensitivity analysis. We're going to hop back into our PowerPoint slide to talk a little bit about what we do with this tornado chart, which comes directly from this model.